Hello everyone, today we will learn that we can write the total angular momentum of a system of a particle can be written as in terms of the velocity of the center of mass and velocity of the particle about the center of mass. Here mathematically this relation can be written as J is equal to it can be written as J is equal to J Cm plus R cross P. This is a very important relation and we will prove it. Here J is total angular momentum of a system of a particle. JCM, it is the angular momentum of a particle about center of mass, and R cross P, it is the angular momentum of center of mass about a reference point. So to prove this relation, first we will consider a reference frame in which a system is present. Let us say it is the z-axis, it is the x-axis, and it is y-axis, and it is the origin. A system has, let us say, the center of mass here, and there is the other particle mi. The position vector of the center of mass about from the reference point is, say, vector r, and the position vector for mi particle from the reference point, say, ri. The position vector of the mi particle from the center of mass, say, is it can be written as, let us say, RIC. From the vector addition law we can write, if we see this diagram here, then we can write Ri, vector Ri is equal to R plus RIC, right? Let us say it is equation number 1. Now if we differentiate this equation with respect to time, then we can write this relation in terms of the velocity also, and it will be Vi is equal to V plus VIC. Let us say it is equation number 2. Here Vi is the velocity of the mith particle about the reference point. Capital V is the velocity of the center of mass about the reference point, and VIC is the velocity of the particle about the center of mass. Now the total angular momentum, we know that for a system of a particle can be written as J is equal to sigma Ri cross P I. Let us say it is equation number 3. We know that Pi is the linear momentum, and for ith particle it can be written as mi Vi. So the total angular momentum can be written as like Ri cross mi Vi. Let us say it is equation number 4. Now we will use the equation number 1 and 2, which was if you remember those, that was equal to Ri was equal to R plus RIC, and Vi was equal to capital V plus VIC, right? So we will use these two equations in equation 4. Now your total angular momentum becomes like J is equal to sigma Ri. It can be written as R plus RIC cross Mi, and Vi can be written as V plus VIC. Let us say it is equation number 5. Now we can write equation 5 if we multiply these terms and add. So we can write like J is equal to, it can be written as J is equal to sigma Mi R cross V plus sigma Mi R cross VIC plus sigma Mi RIC cross V plus sigma Mi RIC cross VIC. Let us say it is equation number 6. Now we can also write equation number 6 as, now note here that sigma will be used for the ith particle. So capital R and capital V are constant. These are the terms for the center of mass. So we can write equation 6 as J is equal to R cross sigma Mi capital V plus capital R vector cross sigma Mi cross VIC plus sigma Mi RIC cross V plus sigma Mi RIC cross VIC. Let us say it is equation number 7. Now if you see here the term R cross sigma Mi VIC and sigma Mi RIC cross V, you will see that these two terms will become 0. We will explain this, that how these terms will be 0. Let us suppose we take the term sigma Mi RIC. Now see, it can be written as sigma Mi. What is your RIC? You know that vector Ri is equal to vector R plus RIC. So here your RIC will be equal to it will be Ri minus vector R. So here it will be sigma Mi, and in place of RIC we will write Ri minus capital vector R. So we can write it as sigma Mi Ri minus sigma Mi R. You know that this term, it can be written as M1 R1 plus M2 R2 if system has many particles, and minus sigma Mi, it can be written as Mr M and capital R. So this term, you know that this term is also equal to MR minus MR, so equal to 0. So similarly we can write the term sigma mi vic is equal to 0. So your final relation for the total angular momentum, it becomes like J is equal to, we can write it as R cross sigma mi, we can write it as capital M. So J is equal to R cross MB plus sigma mi RIC cross VIC, right? So R cross MV, now capital J is equal to R cross P plus, we can write it as JCM. So here we have proved that the total angular momentum of a system of a particle is equal to the R cross P plus JCM. Sometimes it is written as like R cross P is equal to MV plus JCM. This is a very important relation. Similarly, we can write our kinetic energy in terms of the center of mass, and it will be T equal to 1 by 2 mv square plus sigma 1 by 2 mi vic square. This is a very important formula. You have to remember this for the center of mass term. Now potential energy can be written as sigma I bi plus 1 by 2 sigma I sigma j Vij. Here I is not equal to j. Kinetic, you have to remember these three relations. Thank you.